So what we have here is a conductivity tester. I've mentioned this in another video, so if you're hearing this again, I apologize. What it basically is it's basically a lamp socket, standard light bulb socket here, that's been modified. What it did was ordinarily, this plug, the two wires would go directly to the two terminals of the socket. But you'll notice it doesn't. One of the wires goes to one of the terminals. The other wire is connected to a wire, and so it comes out here. The other terminal is connected to a wire. So this is effectively a break in the circuit. So unless there's something, notice this is unplugged, that's why I'm touching it. Unless there's something that touches these two together or something that conducts electricity, this won't light up. So even when I plug it in here in a moment, it won't light up until there's something conducting electricity. Now what we have is we have something called Limewater. This is calcium hydroxide, one calcium, two hydroxides. What I don't have there is that this is aqueous, it's dissolved in water. When it's dissolved in water, it produces ions. So the ions move through the solution and conduct electricity. So what we're going to do is, I'll show you that to you. So this is now plugged in. You can't see, that's probably off screen. I'm going to put the Limewater here, and I'm going to place it so that the two probes are both in the Limewater. And you can see that they are conducting electricity. So what's happening is the ions are moving back and forth through the solution to allow the electricity to flow. We could get into more detail on that, but that'll suffice for now. Now, what if I were to tell you that I can blow out a light bulb with my breath, with a straw? All right, so here we go. You ready? Okay, maybe that's not how it works. So let's try this again, except this time I'm going to put the straw into the Limewater. Maybe I shouldn't use quite so much Limewater. Almost. Ta-da! Now, what's going on here? I'm going to unplug this for safety's sake. So, if we take and we look at this equation, or this formula, it's calcium hydroxide. Now, if you look, you see all kinds of solid in there. So there's two basic reactions that are going on. So this is aqueous. So what this really means is that there are calcium ions and that there are hydroxide ions. So somehow these ions are being taken out of the solution. Well, what is in my breath? One of the things that's in my breath is carbon dioxide. And what's happening is a reaction with water and the carbon dioxide to produce H2CO3, or carbonic acid. So we're making an acid. Now, that does two things. One, it makes it so that the calcium ions can react with the carbonate ions, CO3 2- ions, and makes calcium carbonate. That's chalk, and it's a solid. It's the white solid you see in the bottom of the beaker. The other thing is an acid-base reaction, and I kind of ran out of whiteboard, but what's happening is the hydroxides are reacting with H2CO3 to make water, and more CO3 minus ions that can react with the calcium. So what happened is my breath took away all of the ions that were in this solution, and now it won't conduct electricity anymore.